Hey everybody, I'm Larry. Doing the virtual bi-weekly contest 19. It's a virtual contest. It was yesterday. I missed it because I don't know. I try to do something outside of Leetcode once in a while. Um, there is a little bit of I wouldn't say cheating, but foreshadowing where like they've forced me to see the rankings. So I have some expectations. I don't think I could expect myself to finish in 14 minutes, but I will try to kind of see what happens. Okay. And without further ado, wish me a little luck. I guess it doesn't really matter. There's no real ranking. And I see the name of the thing, which is also a little bit of, I'm not looking at it really. But okay, let's go. Let's start this virtual contest. And here we go. Cool. Starting my problems.
Hey, look, no more ranking.
Yeah. So yeah, the number of steps to reduce a number to zero. Yeah, from this right on, I knew I had simulated. There's no there's no trick, there's no question about it. I knew that this would converge to zero. There's no like weird thing with cycles that we have to deal with. So it's just pure, yeah, coding it. I got this actually end up. I mean, I actually end up getting this really quickly. But I still, I don't know. I mean, I always test my code. I mean, I'm gonna take some time to test my code just because, why not at least test it, because it will cost me 5 minutes if I don't, right? So,
Nice
so that's my
increment
logic.
steps, wouldn't it?
For this first one, but yeah, but otherwise it's just straightforward. I test everything and then I submit it. It was good. I was like, okay, cool. I got it with about a minute. Yeah, number of subarrays of size K. I think the first thing that I just didn't read correctly, maybe, was that I didn't know if K was in a constant, and once I noticed that it was a constant, then it became trivial, in the sense that it's a very,
Rolling windows.
yeah, like a very sliding yeah, like a sliding window problem.
Windows in Python, so I'm just like
So
in my head.
I think I just had some internal dialogue about how to implementing it. I always have some. I don't know. I just always have issues implementing sliding windows in Python because I just have really bad off by ones and for loops that are exclusive and stuff like that. So, but yeah, but I was trying to. Yeah, there is some like code repeating there, but otherwise I was just like, okay, let's just. So for each window, you only need to keep the sum, and because you know the K is a constant, from that you just have to check whether it's over the threshold and then increment if necessary. And there are a couple of ways to handle the edge cases, but I just kind of did it the maybe not the code efficient way, but at least I was convinced that it would be correct instead of like maybe some weird like, because there'll be some additional if statement checks in either way you go. So and I think one thing that I am getting better at it a little bit is using while loops instead of for loops, just because it gels with my mental model a little bit more, at least in Python. In another language, I would still use for loops, but that's because I could control certain things much cleaner. But yeah, cool. Yeah, and after that,
Wish the testing experience
and the testing is
slightly better.
well, a lot better, really. Yeah,
Because essentially I got this done in about a minute, but I'm going to spend another like 2-3 minutes testing.
yeah, they really need to
Maybe I could be more confident.
improve the testing experience for people who like to test, like me. Just a lot of copy and paste here, so that took some time. But
7.7 and
as soon as I saw that it passes, I just submit, and was fortunate that I got it right the first time.
Edge case. Okay.
Cool. Angles between hands of a clock. So this one was straightforward, only in the sense that
Is it angle in degrees?
like it's a problem that people have solved before, right? Like once I've seen it, like I definitely recognize it's a problem that I solved before. I'm just trying to like look to see if there's any weird, I don't know, like just like like maybe it's a variant of a problem that I saw before, whereas it's just like a generic thing, because I feel like everyone has thought about some variation of this in the past, to be honest. Where like,
No,
okay,
that's not right.
and the trick is that, and it's not really a trick. Like I think in the example they tell you the right answer, so I don't like it's very doable. It's just that when the minute hand moves, the hour hand like moves slowly as well toward the next one, so it's not like a discrete thing on the hour hand. I was just
These are
double
all
checking the
wrong.
math, and
So this is the percentage.
and then I realized that I was
This
just doing
is-
it by
this
as a percentage from 0 to 1. Then I just really want to make sure. I guess
that's the
I think
percentage
I
times
had a couple
12.
formulas in my head that I was just a
No,
little bit
times
confused
1
about,
over
but overall,
12 per unit. Okay, because that's the percentage.
pretty straightforward.
Okay.
I mean, yeah, like you may solve this faster or
And then
slower,
now
but
what is the
in
angle?
the concept is straightforward. And then now we have where the hour hand is and the minutes hand is, and then we just have to get the the smaller half of the thing, which I was a little bit lazy, so I just kind of did a min. But you probably could have just done an if statement because the other one would be bigger than half. But
this is a little tricky,
yeah,
maybe.
but here I did not
The other
convert to the
is
360 degree
180
thing, but that's
360
fine.
minus this.
I mean, well, I made that, but okay, I forgot to convert this to. This is in percentage. Yeah, I just have different inconsistent usage, so yeah, that was fine. And then now I was like, okay, I need to start testing other stuff. And again, in this case, yeah, I mean, I'm actually relatively confident about it, but I still want to test because why not? You never know.
450 and 12.0.
But I feel like the tests are mostly exhaustive, especially with the 451. After that looks mostly good, I submitted. Didn't think there were any edge cases.
All right, let's go.
Unless I missed the case. I mean, maybe the only edge case is one was like 12 something, but somehow it got taken care of. But yeah, jump game 4. Yeah, this one I knew kind of what to do it directly. I think I did mix some.
So you could go left or right.
Confusion.
Or J where?
Yeah.
Okay.
So you have like some sort of union find type thing. What is n? N is so
Is it 50,000?
Yeah. Given n is 50,000, we have to do some n or v plus z type things, and this is a graph. Clearly, it's the shortest path problem. Yeah, this is a graph where two nodes are connected if they have the same number on the array. So that's pretty much how I approach this problem.
Okay.
Yeah, okay.
SPFS should be okay.
May note that it is v edges should be at most O of n, so it will be O plus v plus e. The other lab is a little chatty today because of I guess it's a virtual contest. But yeah, it's v plus e. I do make one mistake here, but otherwise it is just a very straightforward BFS thing, except we have to calculate the edge. I guess I had another typo too, but that got caught out in the testing. I should have tested a big case actually, but I did not. Okay, and then now we just do a breakfast. These are just to kind of group all the numbers together with all the indexes, because those are the indices that you have to do a BFS. And the BFS is v plus e, but in this case, at least for now, I thought that it would be the e is O of n or O of v, but you'll see that it was a critical error that I just didn't think about it that much, to be honest. It is something that is fixable, and it is kind of cool in that it's just kind of cool to know that like I feel like I figured it out myself, versus something that I've just seen before, and there are reasons that I explained kind of the logic behind it a little bit later on in the explanation section. But otherwise, this is BFS, and I just implement my thought process right now is okay. This is BFS. Let's get this done. Let's just get this done. This is BFS. I've done BFS probably hundreds of thousands of times at this point.
Edges.
I think one thing to kind of note is that maybe I should have been more explicit in how I define the graph. Or maybe not, but it masked the n square the way that I construct the edge, because I just put it in a hash table, kind of looking up on the lookup number.
I forget one of the cases.
But that's all. This is most of the code actually at this point, and I'm only I don't know 11, 10 minutes in.
Let's go to
return early, and also I think the one case that I knew I didn't do was I didn't do the left and right.
Oh, that's okay.
I was trying to debate how to do it, but I end up just writing its own section.
Where am I now? Okay.
The reason was because I still, I just needed to do this additional check, but I guess I could have just put on the other one. It wasn't a big deal. And that's mostly it. And this is, yeah. I mean, I have a typo that I correct.
5.
Nope. I'll type in the test cases.
Oh, I know it's going to be wrong, but why is this 5 again? How wrong am I? Pretty wrong, actually. How are you going to get 10?
Yeah, so the answer is clearly wrong, just because I had an issue and I wasn't sure quite why, wasn't sure quite why it wasn't working. This part was a very silly typo that cost me about maybe a minute, maybe 2 minutes, which is not a big deal, but, well, it ended up being a big deal. I mean, it's not a big deal because of virtual contests, but it would have been a big deal in terms of, just rankings and stuff.
That's weird. Okay, let's print this out.
Yeah, I printed out and I was like, oh.
Did I do this right? I think so.
Am I not putting? And I noticed that I'm not going to the graphs right. So I was just trying to see why that's the case. And it was only going left and right, really.
Why do I not relax 4? Did I do this 4?
So I did catch this one really quickly. Maybe 1 minute.
4 is relaxed at 4.
1 minute for a problem that I solved in, I don't know, like 7 minutes, I guess, is a big portion of time. But yeah.
Just done now is not right.
Yeah, when I saw that, I was like, oh yeah,
that's an easy fix.
Doesn't make sense. And then I won the code and I submitted, which I was, to be honest, at this point I was confident about. Well, that's not great. Oh no, that cost me a penalty. No, mental note. The syntax error actually,
well,
compile error, just
actual contest. Then
but we could, I ran it again. I hit submit, waiting for judging, and then actually a little unexpected, to be honest. In the moment, I was like, time limit exceeded. Why is that? And then I think it became obvious to me that I was doing n squared because
here
edge stuff. So I was doing that, and I was like thinking about how to handle it. And then I realized that in almost like a connected component kind of way, you relax all the numbers essentially together anyway. And there's something that I explained a little bit later if you want to more. So I just removed all the edges, and then
there's an
that's all right. It took, and that's it. And I solved. This is my fastest contest. Everything else to this guy. Thanks for watching.
Okay.
Yeah. Should have expected that actually, but okay, cool. How long did I end up taking? I made some silly mistakes. So one of them was a real one, and one of them is a compile error that I watched because this is a virtual contest, so I don't really care that much per se. But well, if only that was real, right? But it was easier than usual. I would also say that usually on the morning contests, I'm usually half awake, so I'm not usually performing optimally. And I guess the compile error didn't count, so that's kind of good. But I still got one mistake. I don't know where I am actually in the rank, but it feels good. I mean, it was a breadth first search problem, right? So yeah, let's go over. Excuse me. Let me go over the problems and then we'll see. I mean, I guess I could. No, I mean, anytime you finish something in 15 minutes, I feel like I have had a great day, no matter, even with this silly error that. I mean, it's not really that silly, and maybe it's a little silly, but like. Yeah, I mean, it is interesting, isn't it? Because I did do a little back of the hand calculation on the relaxation. Okay, I'll go over when I get to that problem. But on the first one, number of steps to reduce number of 0. So the first thing to notice about this problem is, the first thing to notice about this problem is that because the current number, how do I even say it? I'm not articulating well today. But no, the first thing you notice is that it's always decreasing towards 0, so you don't have to worry about anything weirdness with like, you don't have to worry about it maybe not reaching 0 or maybe, I don't know. But like there are some other functions where they're similar in style, but it may not reach 0, so you have to do something about calculating cycles and stuff like this. But this one, because you know that it divided by 2 and then it was odd is -1, it's always going to converge to 0. And in fact, yeah, and that's pretty much it. And maybe there's some weird thing. I was going to say is actually, if you really think about it, and I just came up with this now, is the number of, like, we take the binary representation of the number, it's just the number of ones plus the number of digit, something like that, right? But yeah, but you don't have to think about it that way. You just do a simulation, and because n is 10 to the 6, and you're always going to be divided 2 very often, so it's going to be relatively log n, essentially, because you're always going to get from an odd to even number in one number anyway. So at most it's like 2 times log n or something like that, right? So yeah, so knowing that simulation works, so I just simulated, and that's pretty much Q1. Q2. Yeah, it's immediately I knew it was sliding windows. I actually didn't realize the K part, or like and it took me like an extra couple of seconds to realize that was K, because if it's constant, then it makes it way easier. And that's essentially what I do. You just keep track, and then, you know, like traditional sliding windows, every time you push something in, you pop something out, and that's pretty much it. I've been also, I think, as a personal growth level, I've been a little bit better about this particular piece, just because in the past I've always tried to do this in some for loop, which, well, in this case, you see that I did in while loop. So definitely something that I'm mindful of, because I keep on getting sliding windows wrong, or off by one wall. So yeah, so that's kind of that. But yeah, I think that's what I have for this one, really. I think the only thing that's maybe requires a little bit of thinking, but if you have some practice, maybe it comes up, is that I have this function that maybe also a little bit repeating myself. It's just, yeah, the average, or the threshold, the average for the average is the sum over n, or k in this case. So then you could put the k on the threshold side, and that makes it so that you don't have to deal with floating point numbers, which may or may not come in the case, especially with k could be any number, so it could be a little bit weird, or there could be a bad numerical case. But I guess this is easy enough that in theory shouldn't matter. But yeah, that one took me 3 minutes. Guess that's okay. Angle between hands of a clock. I also took 3 minutes on this one. People are really fast. Yeah, I mean, this is essentially a function, right? So I don't really know how to explain it. I think the only tricky thing is, and to be frank, I think I've just done this before, or done. I mean, I've definitely done this problem in some form before, and just a fun problem to think about, or at least in some way. Yeah, I mean, the kind of the tricky thing, which is not really a secret because, as you code it out, you'll probably notice, is that for every minute that you move, the hour hand also move. So that's kind of what I have here, and then you just take the and I actually represent this from 0 to 1, and then just multiply by 360 at the end. But yeah, I don't think I have much of an explanation for this one. You just have to kind of play around and do the maths and stuff like this. Q4. I mean, I knew this was BFS almost right off the bat, which is unfortunate that I have an error. Because without the error, in theory, would have been 5th or 6th or whatever. That would have been pretty cool, actually. But I mean, it's virtual anyway, so so it would make me feel better, but it'll be okay. I focus on the learning. It feels great still. But for this one, I mean, I think I even mentioned during the back of hand analysis, which is that the number of edges is. I think what I was thinking in that terms about space, but I kind of conflated with space and edges with vertices. I said that the number of edges should be of v, which is the number of vertices. Sometimes it could be v, like in a general graph, it could be up to v squared. But in this case, I was doing up to v. But what I kind of, well, I had one silliness was that I just had a thing that cost me maybe like a minute. It's not that bad, but where I conflated the edges and the value of the edge and stuff like that. But the thing that cost me the bad submission is that because we don't clear out the edges, every node or every vertex that you relax, it's going to also have all of up to v edges, right? And in this case, because you essentially relax all the edges that, like you almost think about for two numbers that have the same, for two indexes that have the same number, there's a complete graph of size k for the number of k's that share that number. And then from that, what was I going to say? Yeah, and then from that, you essentially want to relax all of them at the same time anyway. In a way that I think about that way, like it's almost greedy, or it probably is greedy. So that is because of that properly, it enables us to delete the edges because we know that, hey, all the we relax all the numbers that share this already, right? At the same length or +1 or something like that. So we don't have to consider it again because we know that those are already been done. Like the invariant here is that for every edge, it's always going to be best. So like these things are always going to cancel out for the same array index that shares the same number. So that's how I was able to kind of come up with this quickly. But that said, when I first coded, I just wasn't careful about that particular piece. Because it's very easy. It's very easy to kind of fall into a trap in conflating O plus V plus E, which is number of vertex plus edge. That's linear in terms of the input, which is true. But you have to think about what your input really is. And I kind of got away a little bit with that because in this case, V is 5 times 10 to the 4th. So E could be up to, well, that squared, which is very big. Obviously, it's like a billion, right? So yeah, but otherwise, as long as you have this like cute trick, which I actually thought about on the spot, so which is kind of cool. Like I feel like I learned something or like discovered something, which is kind of neat. But yeah, and then everything else is just standard BFS pretty much. Don't think I took that long, but I guess I did take 8 minutes. But definitely people are very fast. So there's definitely some room for growth. Unfortunately, there's no easy way to kind of lock this in and end this, so then I could look at other people's solutions. But I usually I need more, or just like even when I solve everything, I try to look at everyone's solutions just to see how I could maybe type things in a cleaner way, and just learn from people's code, especially like they're not edited, they're like live and stuff like this, right? So I'll do that later. But overall, though, when you finish everything in 15 minutes, it's fine. Like, I mean, it's a virtual contest, which maybe is a little unfortunate in that sense, but it's still, still like when you finish everything in 15 minutes, it probably isn't like I don't have, like I feel great, right? Like like I don't, in theory, have that much to learn. Like, yeah, like maybe I could have spent less time testing if I was confident for this problem, for example, because it was annoying to type, copy and paste these in, and maybe that's how people save some time. But I'd rather test and not be that arrogant about it. But yeah, this one I was okay, and it was easier to test because it's just numbers to type in. This one as well a little bit. So yeah, overall a good contest. Yeah, and that's what I have with this contest. I mean, okay. I mean, I feel like I said, anytime you finish in 20 minutes, no matter rank, even if it's a easy set, and I guess it'll have to be easy for you to finish, or for me rather, to finish in 15 minutes because a lot of people finish a lot harder stuff in 15 minutes. It seems like in these contests, and I know that I have an error, but that was a legit error. So I don't think it was a silly error per se. Like it's something that I could have fixed or could have caught, but I also don't feel bad not catching it because that's kind of a cool thing that doesn't. It's not it's not a common technique, I would say. Um, so yeah, cool. That's all I have for this contest. Cool. I'm going to take a 5-minute water break,